Assalamualaikum warahmatullahi wabarakatuh, Doctor. I'm Amalin from Group 12. This is my group members. Today, I would like to present topic 1 about set theory. Question 12. The symmetric difference of the sets A and B is defined as A delta B equal to A forward slash B union B forward slash A. Draw a symmetric diagram of A delta B and prove D A intersect B delta C equal to A intersect B, delta A intersect C distributive property, and E A delta B equal to A union B forward slash A intersect B. This is the schematic diagram of A delta B. And then for question D, we need to prove A intersect B delta C equal to A intersect B delta A intersect C. Proof A intersect B delta A intersect C equal to A intersect B minus A intersect C union A intersect C minus A intersect B equal to A intersect B intersect A intersect C complement union A intersect C intersect A intersect B complement. Then A intersect B intersect A complement union A intersect B intersect C complement union A intersect C intersect A complement union A intersect C intersect B complement equal to pi union A intersect B intersect C complement union pi union A intersect C intersect B complement equal to A intersect B intersect C complement union union A intersect C intersect B complement, where pi union A equal to A, then equal to A intersect B intersect C complement union C intersect B complement equal to A intersect B minus C union C minus B equal to A intersect B delta C. Proved. Then it is proven that A intersect B delta C equal to A intersect B delta A intersect C. Then for question E, we need to prove A delta B equal to A union B forward slash A intersect B. Prove A delta B equal to A.
For the topic 2, question 1, the question is prove that for any 3 set. The question 1a is A cross B union C equal to A cross B union A cross C. That is Cartesian product of two sets A and B union C equal to the union of Cartesian product of A cross B and A cross C. Now to show these two sets are equal, we know A equal to B if and only if A subset of B and B subset of A. To show this subset, let ordered pair XY belongs to A cross B union C. Now this implies by definition Cartesian product of two sets A cross B contain all such ordered pair XY, X belong to A, Y belong to B. Then X belong to A, Y belong to B union C implies X belong to A, Y belong to B, or Y belong to C by definition of union. Now again we can write this as implies X belong to A, Y belong to B, or X belong to A, Y belong to C. Again, using Cartesian product, we have ordered pair XY belong to A cross B, or ordered pair XY belong to A cross C. Now this implies ordered pair XY belong to A cross B union A cross C. Therefore, ordered pair XY belong to A cross B union C implies XY belong to A cross B union A cross C. Because X belong to A or X belong to B, then X belong to A union B. Therefore, A cross B union C belong to A cross B union A cross C. We name it 1. Now, to prove that A cross B union A cross C is subset of A cross B union C, let PQ belong to A cross B union A cross C. Now this implies ordered pair PQ belong to A cross B or PQ belong to A cross C. Now using definition of Cartesian product, we know P belong to A, Q belong to B, or P belong to A, Q belong to C. Now we take P belong to A, then this can be written as Q belong to B or Q belong to C. And again, by definition of union, Q belong to B union C, so this implies ordered pair PQ belong to A cross B union C. Therefore, ordered pair PQ belong to A cross B union A cross C. Now implies ordered pair PQ belong to A cross B union C. Therefore, A cross B union A cross C belong to A cross B union C. We name it 2. From 1 and 2, we find that A cross B union C equal to A cross B union A cross C. Proof. For the question 1b, the question is A cross B intercept C equal to A cross B intercept A cross C. That is Cartesian product of two sets A and B intersect C equal to intersection of Cartesian product of A and B and A and C. Now to show two sets are equal, we have to show A belong to B and B belong to A. So let ordered pair XY belong to A cross B intersect C, because we know Cartesian product of two sets A and B is defined by ordered pair XY, X belong to A and Y belong to B. Implies that X belong to A, Y belong to B intersect C by definition of Cartesian product. Now this implies X belong to A, Y belong to B, and Y belong to C. By definition of intersection, implies we can write this as X belong to A, Y belong to B, and X belong to A, Y belong to C. Now implies ordered pair XY belong to A cross B and XY belong to A cross C. Now X belong to A and X belong to B, therefore X belong to A intersection B. Therefore, ordered pair XY belong to A cross B intersection A cross C. So we prove ordered pair XY belong to A cross B intersection C. Implies that ordered pair XY belong to A cross B intersection of A cross C. Therefore, A cross B intersection of C subset of A cross B intersection of A cross C. We name it 1. Next, we want to show A cross B intersection of A cross C subset of A cross B intersection C. So let ordered pair PQ belong to A cross B intersection A cross C. Implies ordered pair PQ A cross B and PQ belong to A cross C. By definition of intersection, implies P belong to A, Q belong to B, and P belong to A, Q belong to C. By definition of Cartesian product, we can write this P belong to A, then Q belong to B, and Q belong to C. Implies P belong to A, Q belong to B intersection of C. Again, using definition of Cartesian product, we can write this ordered pair PQ belong to A cross B intersection C, or ordered pair PQ belong to A cross B intersection of A cross C, implies ordered pair PQ belong to A cross B intersection C. Now, implies A cross B intersection A cross C belong to A cross B intersection C. We name it 2. Therefore, from 1 and 2, we have A cross B intersection C equal to A cross B intersection A cross C. Proof.
Hi everyone, I will explain to you the solution of question 6, topic 3. First of all, let's start our proof with left hand side. Left hand side is equal to negative A times in the bracket of B. As we know that the set of real number also satisfy the associative property with respect to multiplication. So, negative 1 times A in the bracket of B. Now we can write negative 1 multiple in the bracket of A times B by associative property. Example, all E, F, and G belongs to the set of real number. We can write that E, F whole into G equal to F, G whole. So both of the equation are equal. Next, we suppose to let that A, B is equal to T and T also be a real number. So we can write negative 1 multiplied by T. Also, by associative property, we can write negative 1 times in the bracket of 1 times T. We simplify that negative 1 times 1 times in the bracket of T. By multiply, we can get negative T. So, by multiplicative identity property, we can write by all G is a real number 1 also is a real number. 1 times G is equal to G times 1, also equal to G. This property said that if we multiply identity multiplicative element in left side or right side of any real number, then we get this real number again. So by the proof, we get left hand side is equal to negative in the bracket of A times B. Then left hand side is equal to right hand side. Hence, we prove that in the bracket of negative A times B is equal to negative in the bracket of A times B for all A, B is a real number.
For topic 4, question 2, real numbers, the question is prove the statement. Question 1, if A less than equals to B and C less than D, and then A plus C less than B plus D. So the proof is, since A less than equals to B, and then we will get B minus A more than equals to 0, it is positive. C less than D, it is also means D minus C more than equals to 0. It is also positive. By the positive axiom, in the bracket B minus A plus in the bracket D minus C is positive. That is B plus D minus in the bracket A plus C is positive. So A plus D less than B plus D. For question 2, if 0 less than A less than B and 0 less than C less than D, then A times C less than B times D. For the proof, 0 less than A less than B, it is equals to A less than B. And then A times M equals to B. In this case, M more than 1 for equation 1. Again, 0 less than C less than D. C less than D, we multiply C with N equals to D, and then in this case, N more than 1. Multiplying equation 1 and 2, A times C times M times N equals to B times D. B times D over A times C equals to M times N. Since M times N more than 1, B times D over A times C more than 1. And then we will get B times D more than A times C. The last equation is A times C less than B times D. So the above equation is true. Question 3. If A less than B and C less than D, then A times D plus B times C less than A times C plus B times D. For the proof, given A less than B and C less than D. So, A minus B is less than 0 and C minus D less than 0. And then we will get A minus B less than 0 and D minus C more than 0. So, in the bracket, A minus B is negative and in the bracket, D minus C is positive. So, in the bracket, A minus B times in the bracket D minus C less than 0. And then we expand it, A in the bracket D minus C minus B in the bracket D minus C less than 0. And then we will get A times D minus A times C minus B times D plus B times C less than 0. And then we will get A times D plus B times C less than A times C plus B times D. So the above equation is true. For question 4, if 0 less than A less than 1, then A square less than A. If A more than 1, then A square more than A. For the proof, 0 less than A less than 1, A square equals to A times A less than A times 1 equals to A. A square less than A, in this case, that means A square minus A equals to A in the bracket A minus 1 less than 0.
This is from topic 5, question 4D. So in order for us to solve this question, we need to substitute number 1 into the equation uk plus 1 is equals to u2k plus 1. So we substitute 1 into the equation and we will get the answer 3. Then we substitute 3 in the same equation and we will get 7. And then we substitute 7 in the same equation, we'll get 15. And we put 15 in the next equation, we will get 31. Same goes to the next equation. We have un is equals to 2 power of n minus 1 in bracket 2, 1 plus 1 minus 1. So the n we replace with number 1, 2, 3, and 4. So we will get the same answer as well. As for the proposition, we have un is equals to 2 power of n minus 1 in bracket u1 plus 1 minus 1, where n is more than or equals to 1. Next, for the basis case, we have n is equals to 1, u1 is equals to 1, and then we substitute 1 into the equation. We will have u1 is equals to 2, 1 minus 1 in bracket 1 plus 1 minus 1. Then we will get u1 is equals to 1, which is true for n is equals to 1. Now we assume true for n is equals to k. uk is equals to 2 power of k minus 1 in bracket u1 plus 1 minus 1. We then have uk plus 1 is equals to 2 power of k plus 1 minus 1 in bracket u1 plus 1 minus 1. Solving this equation using indices as well, we will get the last answer as shown in the picture. So I can conclude that it is true for n is equals to k, then true for n is equals to k plus 1. Since true for n is equals to 1, un is equals to 2 power of n minus 1 in bracket u1 plus 1 minus 1. As for the next question, which is 3 power of 2n plus 7 is divisible by 8 for all n belongs to n, we use induction to prove. How can we solve this question is by letting n is equals to 1 and we substitute the value 1 into the equation, which is 3 power of 2, 1 plus 7 is equals to 16 is divisible by 8. So we try for the next number, which is number 2, n is equals to 2, and we substitute 2 into the equation. So 3 power of 2 in bracket 2 plus 7 is equals to 81 plus 7 is equals to 88, which is also divisible by 8. As you can see, same goes to n plus 1. We substitute n plus 1 into the equation and we will get the answer 9 in bracket 3 power of 2n plus 7. So it is also divisible by 8. Hence, we can see that this equation is proved that 3 power of 2n plus 7 is divisible by 8. For this question, we also need to use mathematical induction. In order for us to solve this question, we also let n is equals to 1, so we substitute the value 1 into the equation. So we will get 28 minus 1, which is 27. We can see that 27 can be divided by 9, which is equals to 3. Now we assume that n is equals to k. 3k plus 1, 7 power of k minus 1 is equals to 9m for m belongs to n. We now prove n is equals to k plus 1. So we substitute k plus 1 into the equation. So we will get 9n. Another way of proving is by using left hand side. We have 3k plus 4, 7 power of k plus 1 minus 9. So by assumption, we will have 3k plus 4, 7 power of k plus 1 minus 3k plus 1, 7 power of k plus 9m. Solving the equation we have just now, we will have 21k plus 28, 7 power of k minus 3k plus 1, 7 power of k plus 9m. Then it will be 18k plus 27, 7 power of k plus 9m. By using factorization, we will have 9 in bracket 2k plus 3, 7 power of k plus m. And we will get the final answer 9n, where n in bracket 2k plus 3, 7 power of k plus m. Thank you.
Now I will explain about topic 6, question 8. The question is, show that no point S of an open interval AB is an isolated point. So for the solution, interval AB is an open interval. R, or the real number, is in the interval AB. Here is the line diagram for interval AB. So for the example, we put the x minus, x and x plus on the line of interval AB. X minus is stand for negative value, x plus is stand for positive value. As if it was an closed interval, x may be A or B. Hence, the value of x plus will be the B plus, which is it is not in the interval. And if x is equal to A, then x minus is bigger and equal to A minus. So this value is away from the interval. The conclusion that we can make here is x can't be the isolated point in AB interval. It only can be the limit point, but not the isolated point. So now it is proven that there was no point of x is the isolated point in the interval AB. So that's all from us, Group 12. Thank you.